What is pH? Let's start with what it stands for. pH stands for the potential of hydrogen, and it's a measure of the concentration of hydrogen ions in a water-based substance. pH is organized into a scale of acids and bases with neutral right in the middle. The range goes from 0 to 14, with 7 being neutral. pHs of less than 7 indicate an acid, where a pH greater than 7 is a base. But why 7? Because 7 is neutral. One of the first obstacles I had to overcome was remembering which number is neutral, which numbers are acids, and which are bases. So I use Lucky 7, or 7 is heaven on the pH scale, to remember that 7 is neutral. And then I know that any number below is an acid, anything above is a base. I also remember by thinking when you base jump, you jump from a high place, so a base must be a high number. Again, remember, Lucky 7 or 7 heaven is always neutral. Next, let's go through some items that are acidic or basic. Milk is slightly acidic, along with apple juice, lemon juice, and then stomach acid. Some acids can taste very sour. Some examples of bases include eggs, baking soda, ammonia, and bleach. And a base may taste bitter, and it could also be slippery. Next, the pH scale has colors that go along with acids and bases. Acids are yellow, then change to orange, then to red. And bases are green, then to blue, and almost purple. Again, remember B for base and blue. So what creates an acid or a base? Technically, pH is calculated as the negative log of a solution's hydrogen ion concentration. But in very simple terms, acids gain hydrogen ions and create hydronium, and bases are created by losing hydrogen ions and creating hydroxide. In very simple terms, acids gain hydrogen and bases lose hydrogen. Each number represents a 10-fold change in the acidity or basicness of the water. Water with a pH of 5 is 10 times more acidic than water having a pH of 6. If you'd like to know more about pH, this playlist will help. And as always, thanks.
Indicators are substances that show different colors when they are in acidic or alkaline conditions. Litmus paper is a simple indicator that tells us whether something is acid or alkali. Litmus is red in acids and blue in alkalis. Litmus paper is made from lichens, which have been used to dye cloth for hundreds of years. It can be used as a liquid or paper. The paper is easier and more reliable. It comes as red litmus paper and blue litmus paper. Red litmus paper changes color from red to blue under alkaline conditions, but no change under acidic conditions. Blue litmus paper changes color from blue to red under acidic conditions, but no change under alkaline conditions. So just remember that red litmus paper changes color for alkalis, and blue litmus paper changes color for acids. However, litmus paper only tells us whether something is acid or alkali, but it does not tell us how acidic or alkaline a substance is. For this, we have the pH scale and a universal indicator. Universal indicator is a mixture of different indicators, or dyes, which has many different color changes, and so shows us the pH value of the solution. Again, it can be used as a liquid or a paper. The pH runs from 0 to 14, with 0 being extremely acidic, 7 being neutral, and 14 being extremely alkaline. Stomach acid is a strong acid with pH of about 2. Acid rain has a pH of about 5.5. Milk is neutral with a pH of 7. Seawater is a slightly alkaline. Soapy water is a strong alkaline. And bleach is a really strong alkaline with a pH of 13. Universal indicator is so called due to its ability to indicate the entire pH spectrum. There are other indicators that can be used that have other color changes, but these two are the ones you need to know. We can also get even more accurate measurements of pH using a pH meter, which will give us readings to 0.01 of the pH. So from this lesson, you should now know indicators can tell us whether something is acidic or alkali and how acidic or alkali it is. Red litmus paper changes colour for alkalis and blue litmus paper changes colour for acids. And universal indicator can give us more detail, indicating where on the 0 to 14 pH scale a solution is. Acids are from 0 to 6, neutral is 7, and alkalis are 8 to 14.